Good. Okay. So we discussed about errors. We discussed about mean. Okay. We discussed that we actually do not know what is the true value of any measurement. Okay. And then we discussed that we will consider the mean value of any measurement of some measurements as the most probable value, or we will assume that this mean value is the value which will be, most possibly the true value. Okay, because that is the mean value of a number of measurements. That is our assumption or understanding. Now here we have a question. We have a triangulation survey where we have measured one angle 8 times. Okay, this is the same angle, but we have measured it 8 different times. Okay, and we have to find out ultimately what is the standard deviation, standard error of the mean, most probable error of the mean, the variance, the maximum error. Okay, these things we have to calculate from this data set. Now we have formulas for standard deviation, etc. This is the same formula that we studied in statistics. Now, so this is from a probability distribution. Fine. The most probable error we discussed that it is corresponding to the 50% error. Okay, so the probability that the error will be within this is 50%. That is most probable error. So remember we discussed a little bit yesterday that what are the values, how the values are. So when we are carrying out a number of measurements, the distribution of the measurement values are something like this. Okay, so this is based on probability. It will be seen based on the law of probability that most of the measurements will be towards the mean value, right? Most of the values will be here. We saw that there is a value called standard deviation, and we saw that 68% of the values will lie between plus minus standard deviation. Okay, within this region. Now, what is 50% error? There is another value, okay, somewhere here. Okay, so this says that this value will give us, okay, let me draw once more. Values are towards the mean value, and there will be one value, okay. So this is what? This is supposed to be the value. Say, for example, this is the mean value, say 100 something, okay, some unit. And here we are assuming that error is 0 here in this region. If a value is there, if a measurement is we have, which is exactly here, so that is 0 error we are saying, okay. So other values will be somewhere here, right? If we have something 1 somewhere here, if we have 2 somewhere here, if we have 3 somewhere here, if we have 4, maybe it is here. Okay. So if 50% of the errors lies within this point, okay, within this, then that is most probable error. Okay. Most probable error. So we have saying this is 50% is corresponding. Okay. So let's go back to the numerical. So these angles are given to us. There are 8 measurements for the same angle. So we are making a table, value of the angle. These are 8 number of measurements of the same angle. So then we added them up. Why we are adding them up? Because we have to find the mean. The mean will be our most probable value. So 605 degree, 36 minute and 0 second is the summation of 8 observation. Then that we divide by how many number of observation? 8 number of observations. So we got the mean value, and that mean value is our most probable value. Okay, now after finding the most probable value, we have to find variations. Okay, what is variations? Variation is the difference between the measured value, difference between the okay, okay. So the variation is difference between the measured value and the most probable value. So the measured value was 75 degree, 42 minutes, 10 seconds. From there, we will subtract the most probable value, that is 75 degree, 42 minutes, and 0 second. Okay. So this is going to be 10 second. So that is variation. Okay. Then 75 degree, 41 minutes, 50 second. From the second value, we will again subtract the most probable value. Now this time we have minus 10 seconds as variations. Okay. Then also we are finding out what is the v square value, because that will be required as per formula to find out the standard deviation. Okay. So these things are easy. What we were given 8 measurement of the same angle. So what we did, we need to find the mean value or the most probable value. So we added them up. We got the summation divided by the number of observation, 8 in this case. So summation divided by 8, we got the most probable value. Then we have to find variation. Variation is what? Difference between the measured value and the most probable value. So measured value minus most probable value we are doing, and we are writing the variations. Unit is second, and then v square, the variation square. Here we are writing down those. Unit will be second square. Now here I'm writing variation is measured value minus most probable value always. The sign, if it is positive, we shall write positive. If it is negative, we shall write negative. Then this is the standard deviation. This point will give us a number. Okay, this formula will give us a number which is going to be within which plus minus within which 68% of the values will lie, as we have discussed. So the formula is the same one that we have studied over time. Variation, summation of variation square here and divided by n minus 1. Okay. So what is n minus 1? N is the number of observation. So this is summation of variation square. We did the square of variations and we added them up. So it is 1200. So 1200 divided by 8 minus 1 square root, right? So the answer is this one. So the answer is plus minus 13.1 second. Okay. So in this case, what will happen? It is like this. This is our most probable value. Okay. And we have plus 13 how much is that? So plus 13.1 second. Okay, 13.1 second in this direction, and minus here minus 13.1 second in this direction. So this is the deviation or the variation from the mean value or the most probable value. And by the law of probability, what will happen? 68% of the measurements will lie in this region. Okay. So coming back here, so this is done. So this is standard deviation. Then standard error of the mean. Okay, so this is the mean of standard deviation, standard error of the mean. So here the same formula, but because it is mean of that value, we have to divide it by the number of observations. So plus minus square root, summation of v square, everything remaining same, but an n is added here. Okay, it is divided by an m, or the number of observation once more, to find the mean value, standard error of the mean. Okay, then the most probable error. So now we will remember this formula. So this is corresponding to the 50% error. Okay, so plus minus 0.06745 sigma. So this is coming out to be plus minus 8.8 second. So in this diagram, there will be another point, another value somewhere here, right? 8.8 second positive in this direction, and 8 minus 8.8 second negative in that direction. So 50% of the values will lie here. So therefore, we are saying that this is the most probable error. Okay. Then most probable error of the mean. Again, now we are considering the most probable error of the mean. So therefore, this is sigma m. This is going to be standard error of the mean, this value. So the formula is same, but instead of standard deviation, we shall use standard error of the mean, 4.6 second, and we got the most probable error of the mean value. Then variance. Variance is just the square of standard deviation. Variance is this, say, variance and variation, they are different terms. Here we were saying variations. So variations is just the measured value minus the most probable value. But variance is the square of standard deviation. So it is another number. We will use it later. Okay. So this is going to be used in the formulas of probability. That is why we need to find out these values. Now, maximum error. So we talked about 99.9% values. Okay, so that beyond which it is maximum error. This is given by plus minus 3.29 sigma. So here in this same distribution, somewhere here, we will have a value. Okay, so this is 3.29 sigma. And here we will have another value. This will be minus 3.29 sigma. What is sigma? Standard deviation. So within these two values, 99.9% of the measurements will lie. Okay. What it is? Corresponding to 99.9% values or measurements. So if we have a value which is beyond this number, so that is considered to be a huge mistake, and that is not to be considered in our calculations further. Okay, so that is then done. So very easy. We were given 8 values. We found the sum, we found the mean, and then we found the variations. What is variation? Most measured value minus most probable value, always that will give us variation. Then we are doing square of the variation. Why? Because it is required in the formula to find out standard deviation. Then these formulas we have to remember: standard deviation, standard error of the mean, most probable error important, standard deviation important. Okay, then maximum error important. So these formulas we have to remember. Then we go to weights. We already discussed a little about weights. Now we will see the allocation of weights. So what was weight? Suppose we have carried out a measurement of an angle only one time, and then another party came, our friend came, and he or she measured it 4 times. Okay, so that means the measurement done by her or him is 4 times more appropriate, okay, 4 times more valuable or reliable, like that, than the one done only once. So that is weight. Okay, if we measure only one time, we can say weight is 1. If we measure 4 times and take a mean of those 4 measurements, then weight is 4. So it is most probably the value which was measured 4 times and taken a mean of those values will be appropriate, will be correct. That is our understanding. Now, how we are allocating the weights? How we are saying that, okay, this is weighted weight 1, this is weight 2, or 4, 5, 6, like that. So there are some laws of the weight. The first law is simple. Say if we are measuring it only once, it can be weight 1. If we are measuring it a number of times, then taking the mean of those values, then it will be the number of measurements. Say, for example, here we see that we have measured the same angle A 3 times and taken the mean value to express the value of A. So the weight will be 3. Okay. So it is 3 times more reliable than a single measurement. If we take measurements for 10 times and take a mean of them, then the weight will be 10, like that. Then if we take weighted measurements, say for example, the same angle is measured by 3 groups, and one group measured it 3 times and noted down the mean value. Another group measured it 2 times and noted down the mean value. And another group, they also measured it twice and noted down the mean value. So this is weighted measurement already, right? Weighted arithmetic mean we have to do now. What is weighted arithmetic mean? The first value to be multiplied by 3, that is our weight. The second value multiplied by the 2, that is the weight of the second measurement. Third measurement also multiplied by the weight of the measurement. And divided by 3 plus 2 plus 2. Okay. So we are taking weighted arithmetic mean of the angle A. So it is like we have now measured it 3 plus 2 plus 2, because one party measured it 3 times, another party 2 times, another party 2 times, right? So it is like we have measured it 7 times and we have taken the mean of that angle. So now the weight will be 7. Then point number 3, if we take algebraic sum or difference of 2 or more quantities equal to the more quantities, then the weight will be equal to the reciprocal of the sum of reciprocals of the weights. Okay, so it is like this. Just say the example. We have one angle A, the value is given with a weight 3. So we have measured it 3 times and taken the average, like that. Another angle B is there. Now B has been measured twice and the weight is 2 because it is measured twice and noted down the mean value. Now what will be the weight of the angle A plus B or A minus B? Okay. Now because we are adding them up or subtracting, okay. So what will happen? This is the law of the weight. It is going to be 1 divided by 1 by the weight of A angle plus 1 divided by weight of B angle, right? So if we do the maths here, it is coming out to be 6 by 5. So because we are adding or subtracting, the possibility of making an error increases, okay? That is why initially it was 3 and 2 for the angles respectively, but now it is somewhere 1 point something, right? 1.1, 1.2. Now the weight is 1.2 for the angle, which is A plus B or A minus B. Fine. So concept is, initially A angle was there, weight is 3. Now B angle is there, weight is 2. But now because we are adding them up or subtracting, the weight decreases. Okay. Possibility of making an error increases, reliability decreases, therefore the weight also decreased to some extent. Okay. Then we have another law. Now this law is for multiplying when there is an angle A and we are finding out what will be the weight of the angle twice A. Okay. So what will happen? We have an angle A, the value is given, has a weight 6, and then the weight of the angle 2A will be how much? 6 divided by square of the weight. Okay. So it's 2 squared. Okay. Uh, See here, the weight is multiplied by a factor, that is, we have an angle A. We want to find out what will be the weight of the angle 2A. Weight of the resultant angle will be obtained by dividing the weight that is there by square of the factor. So initially the weight was 6. Now we are finding twice A, therefore 6 divided by 2 square. If we had been finding for 3A, then it will be 6 divided by 3 square. So again, what is happening? Initially, we had a smaller angle, A. Now we are going for a bigger angle, twice A or 3A, thrice A. So the probability of making an error increases because now we are doing a measurement of the bigger angle. Okay. Then, if a quantity is there, angle A is there, okay, same angle A is there, weight is again 6, but now we are finding out what will be the weight of the angle A by 2. Now, in the earlier case, what happened? A angle is there, and we were finding out the weight for twice A, or a bigger angle. But here, in this case, we have an angle A, and we are finding out the value or the weight for A by 2, a smaller angle. So what will happen? The weight will increase. Okay, the probability that we may make an error will increase. What did I say? The probability that we will make an error will decrease. Okay, so A weight was 6. The weight for twice A by 2 will be 6 multiplied by 2 square. Okay, so you can remember it this way. This is very similar. The earlier one was twice A, so it will be divided, and here it is A by 2, so it will be multiplied. Okay, the opposite. When the angle is going smaller, the weight is increasing, the reliability is increasing. When the angle is bigger, the weight is decreasing, the reliability is decreasing. Then if you have some values, like we have an angle A or A plus B, something, there is a weight 3 already to the angle in the measurement process. Now if we find for another angle which is multiplied, not multiplied, subtracted from a constant value. Okay, say we are saying 180 degree minus angle A, or 180 degree plus A, something like this. Then the weight is not changing when we are subtracting or adding from a constant value. Fine. So these are the rules of weights, how the weights are assigned and how the weights are going to change when the values of the angles or the lengths, etc., are going to change. Okay, so then we'll discuss one numerical. So how these errors will be distributed in the field. Say, for example, we are doing our calculation in the field. Okay. So we are doing calculation, we are measuring angle at the field. So if we have angles like this, okay, we have measured all these angles. So what will happen at the point, if we are measuring the angles, they should be 360 degrees, right? If it is not 360 degree, if it is 361 degree, then there is an error. Okay, we have to minus 1 degree from the measured angles. Then only the summation will be 360 degree, which is the necessary condition. We know that already. This is an established fact, right? So if it is not like that, how we will distribute them? Okay, like how we will correct the angles. Angle A has some value, angle B has some value, angle C has some value, angle D has some values, right? Now how we will correct them, because we have one error of 1 degree. So here are few rules for correcting the closing error. First is, if all the observations are of same weight, okay, all are weight 1 or weight 2, same weight, then the thing is that, okay, the error that we have, the probability that error we have made in all the angles is same because their weight is same. Okay, So therefore, the correction will be distributed equally. Fine. Then the second observation, the correction is inversely proportional to the weight of the observation. First one is so easy. If all the weight are same in the angles that we have measured, then correction will be same. Because weight is same, so the reliability is same. The probability of making an error is same. Okay, that's why. The second is correction is inversely proportional to the weight. So if weight is more, that means the reliability is more. If the weight is 2 here, so the correction is proportional to 1 by 2 in one case. And if the weight is 3 in some case, so correction is proportional to 1 by 3 in the other case. So definitely this is less, right? This value is greater. 1 by 2 is greater, right? This is 0.5 and this is 0.33, right? So if the weight is higher, the probability that we have made an error over there is lower. So therefore, the correction required in that angle will also be lower. Okay. Then the correction applied to an observation is directly proportional to square of the standard error. So the correction is directly proportional to standard error. Okay, square of the standard error. So if the standard error is higher, obviously it is clearly given that that value will require higher correction. So this is again easy point. And the fourth point, in case of level lines, correction is proportional to the length of the line. So this is again a simple point, like we have measurement here. Okay, this is 20 meter, and another measurement we have here, 200 meter. Level lines, okay, here in the same horizontal plane. So definitely the probability that we will make an error in measurement will be higher in the longer value, in the higher value, like so correction will be greater in the longer measurement. So these are few rules of corrections that we will see in the numericals. Okay, let's just see one numerical quickly, very easy. So here we have three angles, angle P, Q, and R. And what is the condition? Closing the horizon. So when it is said closing the horizon, it means the summation of the horizontal angles 360 degree. We are measuring at the same point. So the summation of angle P, Q, and R should be 360 degree, along with their standard error or probable error. So these are probable errors, okay? Plus minus 3 seconds, plus minus 4 seconds, plus minus 5 seconds, those are probable errors. Now first we will add the angles. When we add them up, we see that this is not 360 degree. This is slightly lower than 360 degree. So there is a closing error. So we saw that what is the closing error? Observed value minus true value. So we saw that there is an error, minus 15 seconds is our error. So correction will be opposite in sign, but equal in magnitude, equal in value. So correction will be 15 seconds positive. When we will add that value here, then only this will become 360 degree. So angle P, angle Q, and angle R, all these angles will require a total correction of 15 seconds. Now then we have to determine how much correction for angle P, how much for Q, how much for R. We know the total value, that is 15 seconds. Now standard error is given by the law, by definition, by law we know that correction is directly proportional to the square of the standard error. Okay, so when it is directly proportional, we can write C is equal to constant into E square, right? So we can write C1 divided by E1 square is equal to constant, right? For the angle, first angle, C2 by E2 square is equal to another, the same constant, right? For the second case, then C3 by E3 square is also equal to a constant. Okay, we are considering some constant K, right? But what is the meaning? They are all proportional. So it was like this, right? Correction is directly proportional to the square of the error. So we can write C is equal to K, some constant, in is equal to E square, right? So we can write that C divided by E square is equal to a constant. So then we write for all the angles C1 by E1 square, that is also equal to one constant. C2 by E2 square, that is also equal to one constant. And C3 is equal to E3 square, that is also another constant. So they are all going to be proportional. They are all going to be equal. Then, by rules of mathematics, we can write another proportionality condition. That this will be equal to C1 plus C2 plus C3 divided by E1 square plus E2 square plus E3 square. Right? We can write this by from mathematics. Now this C1 plus C2 plus C3, correction in angle 1, correction in angle 2, correction in angle 3. So this is total correction, right? So this is total correction. This is how much? 15 seconds. We know that already. And all these values are also known. These are standard errors in angle 1, 2, and 3. So we can find out what is this value, right? Then we know this. So when we will compare this factor with this factor, we can find out what is the correction in angle 1. Similarly, we can find for angle 2 and angle 3 by comparing this one and this one in the second case, and this one and this one in the third case. Okay, like that. So that's what we are doing here. That C1 divided by square of standard error, 3 square, C2 divided by square of standard error, 4 square, C3 divided by square of standard error. So this is C1 by 9, C2 by 16, C3 by 25. Then from mathematics, we have this law, C1 plus C2 plus C3 divided by summation of all these three. So C1 plus C2 plus C3 is total correction. So then we got total correction is 15. Then this denominator 50, right? Then we can compare C1 by 9 with the fourth term. So C1 is going to be equal to 9 into 15 divided by 50. So 2.7 seconds. C2 will be 4.8 seconds. C3 will be 7.5 seconds, right? So all these values will be added to angle 1 or angle P. Then the next one, angle Q. Next one, the third value would be third angle, angle R. So we add them and we got the corrected values. Okay, so finally when we will add these values, now the total summation will be 360 degree, which is the necessary condition we know. Now the angles are corrected according to their weights. Okay,